particle of mass 2 kilograms is sliding down a rough slope that's inclined at 30 degrees. So to draw a large diagram, our slope is inclined at 30 degrees. We have a particle of mass 2 kilograms. We have a normal reaction force perpendicular to the slope. We have the weight, which is 2g, and we have the horizontal, or the resolving those forces in the directions of the slope and perpendicular to the slope. We have this angle being 90 minus 30, so this one is 30. So our force down the slope, this one right here, is going to be 2g, and opposite our 30 degrees is going to be sine 30. So that's going to be g. And our force here, perpendicular to the slope, is going to be 2g cos 30, which is, cos 30 is root 3 over 2, so it's going to be g root 3. We're going to have friction, and the coefficient of friction is what we're trying to find, so it's going to be mu r, and our acceleration is down the slope at 1 meter per second squared. So the first thing we'll do is resolve our forces perpendicular to the slope, which is always the first thing we should do because they're in equilibrium. Because they're in equilibrium, r minus g root 3, because that's our force opposite our normal reaction force, equals 0. So r equals g root 3. And then we want to resolve down the slope. So when we resolve down the slope, because I'm resolving down the slope because that is the direction of our acceleration, to keep everything positive in that direction. So down the slope we have 2g sine 30, which is just g, which we'd already calculated. And then up the slope we have mu r. So take away mu r, which is g root 3. And that equals mass times acceleration, which in this case is just 2. So if I rearrange this, mu g root 3 is g minus 2. Mu is g minus 2 over g root 3, which is 1 over root 3 minus 2 over g root 3, which you don't have to do, but it's nice to recognize that you can simplify things a little bit. So 1 over root 3, take away 2 over 9.8 root 3, and it gives us a value of mu to be 0.460 to 3 significant figures.